All right. Translations are very basic. I'm not going to spend much time with this, okay? Because translations are just a slide, right? So if you're asked the number one to do two translations, right? Adjust by -2, 5 and -3, 11. So you can just do it all, and then down here, further down, you're supposed to write. I'm not going to write these image points. You can look at my solution if you want. If you take the 3, 5 and apply the -2, that 3, of course, will become 1. Apply the -3, it's going to become -2. Notice how this is a double prime because we made two movements. And, if I did the 5, I have to add 5, that's going to become 10, subtract 11, that's going to become -1. Again, you could graph these both. Again, it's just a slide. You could graph the prime and the double prime. You can see my solution sheet for that. B, of course, subtract 2, subtract 3, same thing as subtracting 5. And adding 5 and subtracting 11 is the same thing as subtracting 6. If I subtract 6 from 1, I get -5. And if I subtract 6 from that, I get -3. What do we say? Oh, subtracting 5. So, translating is very basic. It's just a slide across the paper. All right. Reflections can be a little bit harder. Reflecting across the X or Y axis, that's simple. So, if I was to reflect, remember, X equals 0, that's the Y axis. So C wouldn't change at all. Whoops, there comes the skip. Let's go ahead and whoops. There we go. Now, if I reflected A across, I'd go 1, 2, 3, 1, 2, 3. So A prime would be right there. B across would be 1, 2, 3, 4, 1, 2, 3, 4. So here is A prime. Here is B prime. Okay. Now, the question said, though, to plot and label the image point reflecting over X equals 0, which we just did, and then Y equals X. So this is something that's going to be a little bit more involved. By the way, Y equals X would be a slope of 1 through the origin. So that would look like that. So we have to reflect over this line. Now, it is a kind of a special line because the slope is 1. Now remember, so we have to reflect that red triangle over the black line. Now let's just mess around with this a little bit, okay? Let's see what happens when we reflect over Y equals X. When we do that, so realize, let's say we had this point here, which is 6, 9. If I was to reflect, I would have to reflect perpendicularly. So perpendicularly would have a slope of -1. So you see, I'm kind of, this point would be right here. And this point would be 9, 6. So what you realize quickly, I hope, is that these X and Y values flip-flop when you reflect over Y equals X, okay? They flip-flop. Now, these are both in quadrant 1, so the signs, we didn't have to do anything about the signs. If they change quadrants, you might have to adjust the sign of the number, okay? But right now, if I reflected, A, for example, you see how it would end up here. A is 3, 5. If I reflected it to here, it'd be 5, 3. You see how the X and Y values flip-flopped. All right. So let me write down my A prime values. this is what? -3, comma, what, 5? B prime was -4, 1. And C, of course, is 0, 3. So if I flip-flop over this, A prime is going to end up in quadrant 4. Okay? So we know that we have to change these. But in quadrant 4, the y value is negative. Okay? If I flip-flop this, watch this perpendicularly. Boom, boom. I'm going to end up in quadrant 4 as well. So these have to change. Okay? But in quadrant 4, that's negative. And here, if I flip-flop this, well, if I flip over this y equals x line, down 1 over 1, down, I'm going to end up on the x-axis. So this would be 3, 0, the positive x-axis. So the bottom line is, when you reflect over y equals x or y equals negative x for that matter, the x and y values will flip-flop, but you just have to give a little bit of thought as to where you're landing and adjust the signs accordingly. Okay? Hope that makes sense. Now, some of the same logic follows with rotations. 90-degree rotation, picture this. If you were to rotate C is 0, 3. If you rotate it 90 degrees, you're going to realize that C is going to end up at 3, 0, right? So when you have a rotating 90 degrees is the same situation as flipping over y equals x or y equals negative x. The x and y values are going to change, and you just have to think about what the signs are going to be, okay? So my original, so that's going to become 3, 0. Watch, I'm going to flip. This is going to be 5 and 3. This is going to be 1 and 4. And this is because it's 90 degrees. Whether it's clockwise or counterclockwise, the x and y values change. And we have to make sure we get our signs right. If we go clockwise about the origin, A is going to end up in quadrant 4. In quadrant 4, the y is negative. B is going to end up in quadrant 4 as well. The y down there has to be negative. X is still positive. That's all we got to do. Obviously, if you rotate 180 degrees, then the x and y values stay the same. Okay? You just have to think about the signs. A dilation, just so you know, a dilation is something like the word dilate. If you get your pupils dilated, the eye doctor means that your pupils are getting bigger, right? So dilation is this, you're given this what's called a K factor. So if this number is bigger than, if the absolute value of this number is bigger than 1, that means it's getting bigger, okay? If the absolute value of this number is between 1 and 0, that means it's getting smaller, all right, your new image. If it's negative, negative means it's going to flip over wherever you're dilating about. Like here we're dilating about the origin. This is positive, so our triangle is going to be on the same side. It's still going to be up here in quadrant 1. If it was a negative number, this would all flip over the origin down into quadrant 3. Okay? So the negative, impacts where it ends up, just so you know. This is simple. All we do is multiply each x and y value by the k factor. So this is going to be 4.5 and 7.5. This would be 6 and 1.5. This would be 0 and 4.5. You can look at my solution document to plot the new triangle. Same thing with the other one. And if this was a 3, we'd multiply everything by 3. If this was a -2, we'd multiply each thing by -2. But I want you to realize if that absolute value is bigger than 1, the image is going to grow. If it's between absolute values between 1 and 0, it's going to get smaller, and the negative changes position. That's what that means. Okay, lots to do here. Plot the point S and its reflected image. So S is 5, -2. Okay. Whoops, I always have this problem on this document. I don't know why. Hopefully I can get this thing to work. You see I had that disappearing ink. Let's see what happens here. Yeah, it's weird. You see the ink didn't disappear, it moved over here to the front page in the same position. I don't know why it does that. Let's see if we can get this thing working again. So 5, -2, because it's really annoying if it doesn't. And then 1, 4 would be right there. Now remember, that's the S and its reflected image 1 S prime 1, 4. Determine the equation of the line of reflection. That's what you're reflecting over. What reflecting over. So I hope you realize I'm just going to do a rough sketch of what's this going to look like, right? It would be something like this, right? It's got to be perpendicular. Again, that's just a rough sketch. So what we want to do is we want to find the midpoint of S prime. And we know that our line of reflection has to go through that midpoint. So the midpoint of these 2 points up here is going to be 3, 1. And then we're going to find the slope of S prime. And that's, of course, going to be what? 4 minus -2 is 6. 1 minus 5 is -4. That reduces to -3/2. So our red line, the perpendicular slope would have to be positive 2/3. And we know a point that it goes through. So we're going to use point slope. There you go. We're all done. Because we know that we find the midpoint of that, the line of reflection has to go through it in a perpendicular fashion. Okay, I don't know if I'm going to do this whole thing. You're asked to graph a segment. You can graph a segment. That should be simple using points. And then it says dilate it. So just multiply the points by 3. So you'd get an x prime of 3, 6. You get a y prime of 6, -9. Okay. And then it says, verify using distance formula. How do the lengths? Well, let's do the distance of x, y, the original. How far apart are 2 and 1 in the number line? They're just 1. Square it. -3 and 2 is 5. Square it. You get square root of 26. Now you want to do the distance of x prime, y prime. So on a number line, 3 and 6, that's difference is 3. Square it. 6 and -9 is 15. I square that, and I get square root of 234. Now that's a little bit harder to simplify, but the biggest perfect square that goes into 234 is actually 9. So that becomes 9 times 234, which is 3 root 26. And you see, yes, 3 times longer. Okay. Okay, not a lot of room here, but I'll have to write small. I'm going to graph the line, -3, down to left, down 2 over 1, down 2 over 1, down 2 over 1. Let's go backwards, up 2, left 1, up 2, left 1, up 2, left 1. So there's the given line. We want to reflect point A, 6 comma, where is that? 6 comma -5. Now again, you could actually do this by counting it out, but I want to show you algebraically. So we have to find A prime. So remember, similar to when we were doing distance, okay? If you were going to do the distance from a point to a line, you'd measure perpendicularly. Here, when we do a reflection, we would reflect perpendicularly. So the perpendicular slope, of course, would be +1/2. Okay? I'm just going to do a rough sketch. If this looks roughly perpendicular, there's our A. Our A prime is going to have to be down here someplace, right? Now, if we can find the intersection of the red and the black, this point here would be the midpoint between A and A prime. So once we know that and we have an endpoint, we can find the other endpoint. So we need this solve the system to find the midpoint. Okay? So the red line, we have the slope, we have a point, we're going to do point slope, y plus 5 equals the slope times x minus 6. Remember, we were given this will come back. We were given this black line, so we're going to take that, we're going to use substitution and solve this system, sticking that in for y. So I get -2x minus 3 plus 5 is what? That would be what? +2. Distribute. Okay. I'm going to have 5/2 x on this side equals 5 on that side. Multiply by the reciprocal. That cancels, and we get x equal, these 5's cancel. This is all nice. You get x equals 2. And then if I plug into this black one, 2 times -2 is -4, -4 minus 3, -7. So we get y equals -7. So we got a, remember, that's the m, that's the midpoint. Okay, 2 comma -7. And our point A was 6, -5. So I could do A prime. How did I get from 6 to 2? I subtracted 4, subtract 4 again. How did I get from -5 to -7? I subtracted 2, subtract again, and I'm done. But that can be deceiving. That only works when your numbers are nice. If you have fractions, that'd be very challenging. Okay, so just remember that answer. I'm going to show you mathematically now. Our A prime, it would be some unknown x comma y. So we know that 6 plus the unknown x over 2 would have to equal this. So if I cross multiply and I move the 6 over, There we go. That's my A prime X value. Now I'm going to do the y's. -5 plus my unknown A prime Y over 2 has to give me this. Cross multiply. And if I move the 5 over, I get -9. So it turned out it was right there. Whoops, that's not true. My line's a little bit off. You know, -2, not -9 is right there, but you know, I was just freehanding this. But my A prime again ends up being -2, -9. Okay. So a lot of work. You have to solve the system to find the midpoint. Notice how we didn't have to use distance formula there, though. No distance formula needed. Okay. This one here, it says, I'm not going to do the graph. I'm just going to give the coordinates. Whoops. And I'm going to talk through it. So if we have 4, 0, and we go 4, 0 will be there, and we go 90 degrees counterclockwise, we're going to end up there. So that's just going to be 0, 4. Remember, 90-degree rotation, X and Y flip-flops. There's H, 7, 0. So if I go 90 degrees, I'm going to be up there. That would be 0, 7. And then this one here, 9, 5 would be in quadrant 1. If we go 90 degrees counterclockwise, we're going to end up in quadrant 2. So you flip these, and then you think in quadrant 2, X is negative. So you're all set.